We have the consent of everyone, and with that we start. Excellent. So hello everyone. Welcome to another session of the VirtualMuleys meetups, and thank you for joining us today. It's always my pleasure to host these sessions with you for our community. And before we start today, there's one thing I needed you to remember. Your feedback is what drives the meaning and the content of these meetups. So at the end of the session, you get that survey, and it's very important for us that you fill it so that we know what you like to see next, so that we can prepare the speakers. Now, very quickly, the four main organizers of these meetups, Manik and Sujo, they're both back in Amer. You have Royston that is leading the APAC region, and then you have myself, Angel Alberici, here in EMEA. Some kind reminders, the new Mule 4 MCD certification that is for free once you complete the self-serve free online course. That's the MuleSoft Fundamentals. Again, it's for free. On point number 2, you have for any training queries, this has been a common question. There's a new ticketed system, help.learn.mulesoft.com. You can find all the information there. And for any doubts, as per usual, you can use whether Stack Overflow or the MuleSoft forum. Now, for these are some of the rules. So pop your questions in the chat and anyone can try to answer them. The questions that are not answered, we will have some time to ask in your behalf at the end of the session. The recordings, as always, they will be in both the Meetups page and the VirtualMuleys YouTube channel. And again, your feedback is what drives the content of these meetups. So at the end of the session, you receive a survey, fill that survey with what you want to see, and we will accommodate that for you. Now, some exciting announcements and updates. We start with the pre-alpha of the DataWeb Playground and tutorial. Again, this is not officially released and it's not a MuleSoft supported product, but you can start playing with it. So some of you may have already seen it and may have already played with this the twlan.fun address, where you can have your DataWeb in your browser. But what is new for today, or for the last couple of weeks, is the tutorial tab. So tutorial tab means that you can go into your browser and go into the section of tutorial, and you will see the tutorial documentation in the left, and you will have your code snippets of DataWeb in the right. And this will allow you to do a more step-by-step practice of DataWeb. And if you want to master any of the concepts specifically, you already have the examples prompted. So you don't need to go into another place. You have everything there right from the browser, hosted by MuleSoft. Now, it's very important. Please pay attention here. There is a disclaimer. This is not an officially supported MuleSoft product, and it's not supported by the MuleSoft support team. You are not able to open MuleSoft support cases for this tool, and there will be no SLAs. This disclaimer is very important. You can go, you can practice, but please don't open support cases. Instead, what you can do, you can go to the repository, the official repository, and you can do pull requests or report the issues that you're seeing. I did it myself. I added that disclaimer to avoid frustration from both sides. Now, interesting news, the hackathon, you can submit until the 29th of November. Make sure you check it out. There's they say amazing prices, because we're talking about around $10,000 in total for the winners. And you can see the conditions that apply as well in those links. I will share a master slide deck that you can check all these links later on. You will have it right after my session. And next, MuleSoft Studio, Anypoint Studio 7.7. If you haven't worked with it, that's perfect, because we have aligned for next week a great session, Anypoint Studio 7.7, with a deep dive right from the MuleSoft engineering back in Buenos Aires. It will be led by Eric Mastrangelo and Marina Rivero next week. You can sign up already. It's already published. So if you're interested, make sure that you are RSVP now. Another small disclaimer here and self-advertisement, the Friends of Max videos, if you haven't seen it, it's an initiative of videos that are between 5 to 10 minutes, very short, but they focus on a specific topic. So we try to enable you as fast as possible by a self-serve manner. One example is the continuous integration and continuous deployment video that we just released last week. Basically, It's very common in organizations that don't have anything as CI/CD, that is hard to articulate to business or to tech leads, for example. What is the value on CI/CD? Why is important? So that's covered in this video, just as with an overview of what it is and how it fits into MuleSoft. Another of the releases, the multi-factor authenticator. This was requested a while ago, so now you will have something you know, the login credentials of your Anypoint platform, and something you have that will be the authenticator, whether it's the Google Authenticator, whether it's the Microsoft Authenticator, whether it's a security key as YubiKey, and you can see the rest of them in the slides that I added in the link with all the links into the chat later on. Now, the last one, before we start the sessions today, to take advantage of the Design Center new feature of multi-tabbing. As a developer, I saw this before. I was having some struggles because I wanted to have multi-tabs in Design Center, and that was not possible. Now it's released, so you can start playing with that one as well. So finally, for today's, we have both Arno and Anu, and I wanted to thank both of them because they put the time to present today and for the interest in sharing with the community. Anu, she's based here in UK with almost 20 years of field expertise. She was focused mostly in what is IT delivery and professional services. And after around 13 years of working for the same small company that grew into a big corporation, she decided to move, and she joined us around 1 year ago. In the case of Arno, he has an incredible record. He's our key strategic advisor and part of the office of the CTO, and I'm sure he has prepared a better introduction. So I'm not going to add more into that yet, and just let you know that he's tuning in from the Netherlands. With that said, Arno, I will stop my screen sharing, and I will give back the access to you. Please take the stage, and thank you for leading the presentation.
Thank you very much, Angel. I'm going to share my screen now, and then we'll start with the presentation. So
we're able to see your screen.
Yes, perfect. Thank you very much, Angel. So good morning, good afternoon, and good evening. Welcome to this MuleSoft meetup. My name is Arno Brugman. I'm a strategic advisor. And before we start, I have to show you this because I will touch on some future functionality that is part of our runtime fabric. So the safe harbor statement basically means that you should never base any buying decisions on information that contains futures. And the reason for that is very simple. Those futures are plans. They're not set in stone. So when you make buying decisions, you should always base them on existing versions of our software. So starting with our presentation, like Angel so gracefully said, I'm the oldest one in the team. 30 plus years in IT, 4 years in MuleSoft, and I'm a strategic advisor in customer success. What does that mean? It means that I work together with our most ambitious customers in EMEA, and I become their trusted advisor for MuleSoft, for product, for technology. And I also become their customer advocate back into our strategy and our product divisions to share what our customers are doing so that we keep alignment between our product and the plans of our customers. So today's presentation is about containerization, and specifically containerization of the Mule runtime with Kubernetes. I have a very strong opinion about that, and I will share that with you. And I've shared the agenda previously. So quick introduction about containerization. Then I'll share some containerization environments and what we typically see with our customers. I'll touch on how you containerize the Mule runtime with Kubernetes, how to build the image, how to deploy applications, what to do in CI/CD, and finally, I'll share some information about Runtime Fabric and the future of Runtime Fabric. So let's start with the introduction of containerization. I've noticed that many people think that containerization and Linux are very hip and fresh and young, but the truth is that the origins of Linux started in 1963 with Multics, and then in 1969 with Unix. And yes, that's how you spell Unix, with CS. It was later changed to Unix with an X, but it's very old. Just for comparison, the grayed out operating systems, MVS or ZOS, IBM's mainframe operating system, wasn't started until 1974. VAX VMS started in 77. And then in 79, the first version of containerization was created, and that was change root jail or crude jail. That was in 79. That was 4 years before Windows was launched. In 1991, Linus Torvald created Linux, and it took until 1999 for VMware to launch their first workstation. The current versions of containerization are all sort of based on Linux containers, or LXC, that was launched in 2008. And Docker was basically created 5 years after that, and it's very much based on LXC, on Linux containers. What's interesting is that when I started looking for definition of what is a container, the first definition I found was by Docker, and it's a very technical one. Container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. And then I saw the second one, and this is more of a business type definition because it also contains the why and the advantages. So this one says a container is an abstraction at the application layer that packages code and dependencies together. Multiple containers can run on the same machine and share the OS kernel with other containers, each running as isolated processes in user space. But now it comes. Containers take up less space than virtual machines, can handle more applications, and require fewer VMs and operating systems. So that's where the advantage is. So this is probably the better of the two definitions. So if we look at containers versus virtualization, they both require infrastructure, but a container requires a host operating system, whereas a virtual machine requires a hypervisor. And then you have Docker as the underlying mechanism for building and running the containers, whereas on the hypervisor, you need a virtual machine with a guest OS. And when you have all of this in place, then you can run applications. Now, I'm not saying that you can run 9 applications in Docker and only 4 in a virtual machine. That's just a graphic. But it is true that Docker containers have less overhead because they don't require additional guest operating systems on the same infrastructure. So therefore, it should be able to process more application logic than a virtual machine. I hope that's clear, and if not, then I'll read the questions later on in the session. Containerization environments. There are a lot of containerization environments. From Alibaba to SUSE, many companies have created their own containerization environments based on Kubernetes or based on other container services. Alibaba has both Kubernetes-based and a container service. Amazon, the same thing. They have the Elastic Container Services and the Elastic Kubernetes Services. Canonical, Google, Gravitational. That's an interesting one because that's the Kubernetes distribution that MuleSoft used for the first version of Runtime Fabric. So everything version 1 to 1.7 uses Gravitational's Kubernetes distribution as the underlying technology. And then, of course, Microsoft, Oracle, Rancher, all these different environments came from different areas with different customers in mind. But if we go and basically filter out the environments that MuleSoft sees in use with the customers, we see two things. In the cloud platforms, all we hear are Amazon, Google, and Microsoft. So EKS, GKE, and AKS. And for on-premise, we basically find two environments that are prevalent among our customers. And this is mainly in EMEA, because that's where my work territory is. We see Red Hat OpenShift, and we see Pivotal Cloud Foundry. Those are the environments that I run into when I work with customers on a day-to-day basis. And I also see that there's a strong migration towards the cloud-based platforms. Microsoft, very strong, Amazon, very strong. So those are the two platforms that are most prevalent and that we see most used by our customers when we talk about containerization and also for development environments. So next step is containerization or containerizing the Mule runtime with Kubernetes. Now, why would you do that? What is the advantage of containerizing a Mule runtime instead of running it on a standalone server? So I've tried to illustrate that with this graphic. And on the right side, you see the standalone Mule runtime. That Mule runtime runs on a server, and you have a number of applications running on that Mule runtime. On the left, you have a Kubernetes environment with pods, and each pod has a Mule runtime and a single application. So that's a big difference. Basically, that means that in the Kubernetes environment, you're running a Mule runtime for each application. So what are the advantages? The advantages of using containerized Mule over a standalone environment are, first of all, application isolation. That means that you get dedicated CPU, dedicated memory, and dedicated disk space for each application. So applications don't compete with resources for other applications. Also, it is configurable, where on a standalone Mule runtime, you have a maximum amount of memory, and all the applications compete for that memory. And if one application is stealing memory away from another application, then that application might become impaired or get in trouble. So it's very important to have dedicated CPU, memory, and disk for each application. And on top of that, it's also configurable. So if we compare it to, for instance, CloudHub, if you select a worker, that worker always has a fixed amount of memory. But when you use Kubernetes, you can basically assign a certain amount of CPU capacity combined with a certain amount of memory and a certain amount of disk. And those are not linked like in CloudHub, but you can have a small CPU with large amount of memory, or a large CPU with a small amount of memory, and so on. One of the advantages is also that you can scale both horizontally and vertically. So what that means is, if you are running a container and you see more and more requests coming in, then you can choose to either instantiate another version of that pod to cope with the increased workload, or you can do vertical scaling by redeploying the application with more CPU and more memory. So both versions of scaling are possible when it comes to running your runtime on Kubernetes. However, when you implement a Mule runtime on Kubernetes, there are a number of features that are not available, like features that are currently available in CloudHub. So the first one is automated load balances, or automatic load balancing. If you want to run multiple instances of a pod, then you will have to take care of the load balancing yourself. Also, when you instantiate pods, there is no zero downtime redeploy. Where in CloudHub, if you redeploy your application, what it will do, CloudHub will start your new application, and by the time it's fully functioning and operational and can receive requests, that's when the old application is turned off. So that means zero downtime. There's not a single request that gets lost. And that is a feature of Cloud Hub, but you would have to build that yourself when you containerize your Mule runtimes. The next one is a very obvious one, and that is that if you want to create containers with the Mule runtime, you would have to build your own image, starting with the operating system and the JDK, etc. And once you have that image, if there are updates and patches on the Mule runtime, you would have to apply those patches yourself. So you would have to take the newest patch or the newest release of the runtime, create a new image, and then redeploy applications with that new image to take advantage of the new patches. And that would lead to downtime unless you actually implement zero downtime redeploy in your containerized Kubernetes version of the runtime. There's another, however, and this is something that I noticed with a number of customers that have been very successful and created a large number of applications and containerized them. So one of my customers now has well over 300 Mule applications running in a Kubernetes environment. And one of the disadvantages of doing it this way is that all these pods will want to connect and update the Anypoint platform. And what we found was that their proxy capacity in terms of the number of connections and the throughput of data wasn't up for the task. So they actually had to upgrade their proxy to make sure that the communication between the Mule runtimes and the Anypoint platform, in this case, Runtime Manager and API Manager, it required their network to be upgraded, their proxy to be upgraded to handle the large number of connections and the amount of data coming through. So this is something that you have to keep in mind when you decide to containerize your Mule runtime and have it managed by the Anypoint platform. So building the image, I'm not going to share scripts or Docker files of how to build the image. There are plenty of examples by people of how to create a Mule-based image. And obviously, it needs the operating system, it needs a JDK, it needs the version of the Mule runtime that you want to use, and you need a license file. What you need in terms of hardware is a 2 gigahertz CPU or one virtual CPU with similar speed, 1 gigabyte of RAM minimum, and 4 gigabytes of storage. And then you need Red Hat Enterprise 7, JDK 1.8 or JDK 11, the Mule runtime, in this case, version 4.3, and your Mule license file. There are two ways to deploy the application into that container, into that Mule runtime. And from what I've seen online in the different versions of Docker containers that are out there that you can reuse, is that most of them are unmanaged. So that's method one. And by unmanaged, I mean the application is simply copied. The application.zip file is simply copied into the container, and then the Mule runtime is started. That means that it's not managed by Anypoint Runtime Manager, because for that you need to set up a connection from the Mule runtime to the Anypoint platform. And that's method two. So when you have your base image and you start the Mule runtime, you need to do a little bit more. You need to install and activate the Runtime Manager agent. You need to upload your application using either the command line or the API into the platform. And then you need to use the Runtime Manager, again, using the command line or the API, to deploy your application into the container, and then it's running, and then it's managed. So those are the two very different ways of deploying applications into a container. So for CI/CD, that means that when you're starting up a container, after starting, you need to connect the runtime to the Anypoint platform, and you need to use the API, the Anypoint platform API, to register that runtime so that it becomes a managed Mule runtime, and therefore you see the application in the Anypoint platform. Now, there's also something that initially when you start containerizing, you may forget, and that is what happens when the container is shut down. When the container is shut down, the Anypoint platform will start screaming that it can't find the application, it can't find the runtime anymore. So if you're stopping a container or shutting down a container, that container is terminated. And when you restart it, or when you initiate a new container, it has a new name and a new IP address, and it doesn't take the connection of the previous container. So in order to make sure that you don't end up with a Anypoint Runtime Manager full of unmanaged applications or applications that are no longer there, you need to make sure that you deregister the container from the Anypoint platform before you actually shut down the container, so that you clean up the Anypoint Runtime Manager and tell it that this container is no longer to be managed by the platform. So we have a large number of customers that have different reasons for not wanting to use CloudHub. Most of them are to do with security decisions, governance, or even regulatory decisions. So some government is not allowed to use cloud applications. Some banks have rules, internal rules, that basically say customer data cannot live in cloud applications, and so on. So there are many customers of ours that, for one reason or another, do not want to run all of their estate in CloudHub, or none of their estate in CloudHub. So for those customers, we have created Anypoint Runtime Fabric, and it allows you to run Mule runtimes on-premise in a managed environment, which means that you get the same type of functionality and features that are available in CloudHub for your on-premise applications. It also allows you, if you have presence in both on-premise and CloudHub, to manage all your applications from a single point of control, single pane of glass. Runtime Fabric uses Kubernetes, and in its first version, its first form, it uses the gravitational Kubernetes distribution. And it allows, or it creates containers of the Mule runtime, and allows you the horizontal scaling, the vertical scaling, and auto redeploy by default. So all those features that people know from CloudHub and would like to, or maybe need to, implement on-premise are available in Runtime Fabric. And the advantage of this is that it's the same type of implementation as in CloudHub. In CloudHub, if you instantiate an application in a worker, it creates a virtual machine with one application, just as in Kubernetes, where it creates a pod with one runtime and one application. That means that you're able to fairly quickly move applications from Cloud Hub to private cloud and back to Cloud Hub again without any impact, because the way it's implemented is exactly the same, namely single runtime, single application per runtime. So Anypoint Runtime Fabric, what are the advantages? What are the benefits of using Runtime Fabric over standalone runtimes? Well, first of all, I mentioned it earlier, the horizontal scaling and vertical scaling. Because you have multiple worker nodes, if an application fails, it can automatically be restarted on a different worker node. If you need more capacity, you can instantiate that same application multiple times over multiple worker nodes. That means that you can increase the capacity of a single application really, really fast. The other advantage, and I think this is especially an advantage for customers who are migrating from Mule 3 to Mule 4, is that in Runtime Fabric, you can run multiple versions of the Mule runtime in the same Runtime Fabric. Just as in Cloud Hub, you can deploy an application on Mule 3.9, 3.94, 3.95, 4.2, 4.3, etc., next to each other. Whereas on a standalone runtime, there's only one version. If you want to be able to run 3.9 and 4 next to each other, you would have to have 2 bits of infrastructure. So you need a Mule 3.9 server and a separate Mule 4 server. Now, I've had a number of customers ask me if it's possible to run Mule 3.9 and Mule 4.3 on the same infrastructure. And in practice, I've learned that that infrastructure is scaled to run all the applications that are in production on Mule 3. Now, if you're going to steal away half of the resources from that infrastructure for Mule 4, then you're basically stealing away capacity, CPU, and memory from existing production applications that were running fine on that infrastructure. I've not seen a single customer successfully install Mule 4 on top of Mule 3 in the same infrastructure. So my guidance and my advice is always to have a separate bit of infrastructure, separate server or separate cluster for Mule 4 when migrating from Mule 3 to Mule 4. In Runtime Fabric, that's not needed, because in Runtime Fabric, you can take a Mule 3.9 application and redeploy it as a Mule 4 application without having to change infrastructure or whatever, because you have the ability to run 3.9 and 4.3 side by side. Again, you're able to scale horizontally and vertically, so you can redeploy the application with more memory and more CPU, or you can just deploy an additional copy of the application, scaling horizontally, and you can do that with zero downtime. So it's zero downtime redeploy. You don't miss any transactions, and it's as if the application was never stopped. That is difficult to build yourself. So if you're thinking about containerizing, you'll probably have to explain that when an application is redeployed, there will be downtime, where in Runtime Fabric, there is zero downtime when you do a redeployment. So a quick fix or a quick update to an application in a containerized environment will definitely lead to downtime. So the advantage is also that Runtime Fabric is connected to the Runtime Manager. And that means that you get all the features and functions of the management plane for all your runtimes that are running in Runtime Fabric on-premise. And finally, flexible deployment on existing infrastructure or managed Kubernetes services. The first version required virtual machines. Later on in this slide deck, I will show you that the future will allow you to run Runtime Fabric on other flavors of Kubernetes than the gravitational distribution that we used for version 1. So as of, I think, last week, we now provide Anypoint Runtime Fabric on EKS and AKS. Version 1 required you to provide a number of virtual machines to run a, let's say, soft appliance version of Runtime Fabric on, and those machines together formed a Runtime Fabric that would connect into the Anypoint control plane. With this latest release, it's now possible to use your own existing EKS or AKS environment and run Runtime Fabric on top of that. At this moment, that needs to be a dedicated cluster for Runtime Fabric. In the future, that will change. So how does it work? I think it's very similar to what Runtime Fabric does now. It allows you to take a Azure Kubernetes cluster or a Amazon Kubernetes cluster and install Runtime Fabric, and it allows you to run applications in Kubernetes containers, in pods, isolated, with a number of advantages over doing it yourself. I think one of the biggest advantages is the fact that you have zero downtime redeployment, because that is an enterprise scale requirement for containerizing the Mule runtime. You need to be able to update applications without downtime. Second, per cluster, per runtime fabric, there is a single connection to the control plane. So instead of in the previous picture where I showed you that every pod was connected to the control plane, with Runtime Fabric, there's a single connection. So each pod talks to the Runtime Fabric and Runtime Fabric talks to the control plane. That means that you have a single connection to the control plane per Runtime Fabric instead of as many as applications or pods you're running. That causes a lot less overhead on your network. And it basically means that the traffic between the Runtime Fabric and the control plane is optimized tremendously. And again, feature parity for Cloud Hub and this Runtime Fabric running on AKS and EKS. And as you can see in the next slide, on the left is where we are, where basically we have the first version of Runtime Fabric running on existing Amazon or Azure virtual machines, where you are able to deploy the first release of Runtime Fabric, and it uses Kubernetes as in the gravitational distribution. The second step is the first versions are EKS and AKS. Those are available now. GKE will be available in the near future. Basically opening up managed Kubernetes environments, not using gravitational, to install Runtime Fabric and to run Mule runtimes on. And this allows you to use your existing Kubernetes expertise of the platform of your choice. You don't have to learn gravitational, and you basically can continue using the people that have built your Kubernetes expertise in your organization. The next step is the addition of OpenShift. So GKE is later this year, OpenShift is next year, and that basically means that we will start supporting Runtime Fabric on the OpenShift container platform, and it will allow you to run Mule and non-Mule workloads on the same Kubernetes environment. So in the previous step, it was a dedicated cluster. In the next step, you can mix Mule runtimes and non-Mule workload on the same Kubernetes cluster. And then the final step in this evolution is that we will run across any Kubernetes-based server. We will provide open support for any managed service that is built in Kubernetes, and we will be able to deploy across any Kubernetes environment. So I want to thank you for your attention. Angel, shall we move on to questions?
Yes, indeed, Arno. We have a couple of those. There are some. We're going to start from some more basic ones. So before we start, actually, there's two shout-outs. Nicely explained, Arno, by Gonzalo Marcos and Tony De Fusco. This is the best detailed explanation I have seen in the topic. Those are two.
Perfect. Thank you.
And now we're going to move to the questions. The first one is from Rolando Carrasco. The question is, the ability to deploy on Kubernetes will be great, but for Pivotal, it's not going to happen. Is it only for OpenShift?
So for Pivotal Cloud Foundry, we used to have a deployment, and we used to have a package, a Mule runtime package, specifically built for Cloud Foundry. And if I'm not mistaken, that was three and a half years ago. And we spent a lot of energy and a lot of time building it and maintaining it. And I must say that in the whole of EMEA, all of the customers that I worked with, we had one customer on Cloud Foundry, and they moved away from it because they found out that it was very difficult to get applications to run on it. So it's not one of the top tier products, but if they have a pure Kubernetes environment, then in stage 4 of our roadmap, we should be providing support for Pivotal as well.
Okay, thank you for that, Arno. And just sharing a little bit of my experience as well with PCF, one of the main issues was related to cost. Just adding I'm going to leave that wound open. And with that, we move to the next question. That is well, this was already answered by Mario Martinez around Runtime Fabric on PCE. It was a question from Jorge Peroso. That is already answered. So we move to the next one from Bikram. Is it officially supported to run this on GKE in the Google?
So GKE, so the Google Kubernetes implementation is not yet supported. At this time, you can create a dedicated cluster on Amazon and Azure for the latest version of Runtime Fabric. GKE customers need to wait for a couple of months, and we will provide this before the end of our fiscal year. So that's January at the latest.
Okay. Thank you for that one, Arno. Yeah, there was another one related to the limits of applications per core with Runtime Fabric. I'm not sure if that will be, if we just can share the documentation, or you have that number on top of your mind, Arno. I don't think.
So I think that's a very good question, because the answer is not in the documentation. And the reason for that is there is indeed a minimum amount of CPU that you need to assign to an application, and that is 0.02 vCores. That's the minimum. And that might cause you to think that you can run 50 applications on a core. But in reality, that's not true. 0.02 vCores assigned to an application, that is when it's resting. That is when it's started, fully operational, and when it's a really, really light application. But in Runtime Fabric, you specify the base CPU power that you want to assign to an application, but you also assign the maximum CPU power that you want to assign. And you need to assign a little bit extra for it to start within an acceptable time frame. If you assign 0.2 vCores to an application and only that, it can take up to 40 minutes for that application to start. So in order to make sure that you can run as many applications on a core in Runtime Fabric, we recommend that you specify the base CPU as low as possible. And you have to be comfortable with that, and you have to do rigorous performance testing to make sure that the application will actually run on that minimum CPU. But you also need to keep capacity on your Runtime Fabric for that application to burst, not only for the start, but also when you're seeing unexpected high use of that application. And in that way, you're stopping issues, or you're preventing issues with applications. So I think technically, is there a maximum number of applications that you can run on a single core? Theoretically, yes, it's 50, but if you do it that way, you have to prepare for a very long wait for those applications to start. So in real world, in real life, I would say between 30 and 40 is more realistic. And you need to leave room on every Runtime Fabric, on every cluster for applications to burst as well. So set the minimum CPU capacity wisely and make sure that there is something available for those applications to burst so they start up in a normal fashion. And even when they are a bit stressed because of usage, that they can burst so they have plenty of CPU available.
And this will be recorded, so in case that you want to reuse all that knowledge that Arno is sharing right now in the Q&A, you can also query it on the VirtualMuleys, because I know there's so many different questions around this topic. We still have around 6 to 7 more, Arno.
Pretty good.
Okay, so the next one is from Tony DeFusco. It's about the customer with the 300-pod containerized Mule application set up. They needed to have 300 cores, vCores licensed with MuleSoft. This is a question around licenses. So 300 pods containerized with the Mule application set up. They needed to have the 300 vCores cores licensed with MuleSoft as well.
No, they don't. So if you can prove to MuleSoft that you are assigning a fraction of a core to an application, and this is possible in Kubernetes, you can basically define up to 0.01 core per application. So if you have really small applications like 300 hello worlds, then you can assign 0.01 core to that one application. So if you have 300, you would need 3 cores. In this case, the customer that had 300 applications had a all-you-can-eat license. So there was no issue with the number of cores they needed. But you don't need a core per application. And in Kubernetes, you can assign fractional cores to applications. So you can run, let's say, if you have a 10-core license, you should be able to run up to 300-400 applications easily.
Okay, that's a great answer. Thank you, Arno. And this is just a comment, actually, from Tony DeFusco. It's around his employer successfully run Mule 3 and Mule 4 runtimes on the same server on-prem. It's just a comment.
I would like to comment on that. I know that theoretically it's possible. The problem is, if I look at our typical customer, they have a limited license for the number of cores they can use in production. So let's say they have a 4-core cluster and they're running 50 applications. Now, if you want to run Mule 4 on top of that cluster with 50 applications running Mule 4, then you're basically going to steal away half of the capacity of the cluster. And that cluster was built based on the capacity required in 3.9, and you're cutting 50% away. So there's no situation where you don't run into trouble. You will run into trouble when you put 2 JVMs and 2 Mule runtimes on the same infrastructure, unless you've sized it with 16 cores and you only need 2. That's the only scenario where you were so oversized that it's easy to run an additional Mule runtime. But I've never seen a customer that said, you know what, we only need 2 cores, but we'll buy 16.
Fair enough, Arno. Thank you for giving your feedback on that one. The next one, there's the 3 more here. That one is around the proxy bandwidth you highlighted, dependent on what you're doing with your control plane. Why there is so much traffic, assuming you're talking about a scenario with lots of chatter, such as that from Anypoint monitoring?
So what happens is, in a self-containerization environment, every pod needs to set up its own connection to the runtime plane. Now, each connection generates a lot of overhead. And that means that if you have 600 or 300 or 200 pods connecting simultaneously to the platform, the proxy will see a lot of overhead from those 200 to 400 connections. And in this case, our customer had a big issue because they saw connections dropped by the proxy. They saw data being rejected, and basically they found themselves having to start runtimes again and again and again. And when they finally went to their network provider and said, can you tell us what the problem is? They said, yeah, you have way too many connections. This proxy is okay when you have up to 500 connections. And this was the same proxy that was used by all the employees to go through the internet. So there was no bandwidth. And in this case, the customer had to triple the capacity of the proxy to ensure that the 300 applications would connect into the Anypoint platform successfully. They are going to move sooner or later to Runtime Fabric, and then that problem will be gone because they will have maybe 6 or 7 Runtime Fabrics, so they will have 7 connections instead of 300.
Okay, that answers the question. And moving on to the next one, Arno, we have 2 more. So what is the memory overhead of Mule runtime in a container? Can it be put into a shared memory space, meaning a .so?
That's not recommended. What is the minimum memory space? So if you look at the containers in Runtime Fabric, what we do is we do 50-50. So the minimum memory size that we recommend for a container is 1 gigabyte. And if you look at the wrapper.conf in the Mule application, it says use 50% for the Mule runtime. So it will allocate 50% of the 1 gigabyte for the Mule runtime. I have seen customers who've actually changed that percentage, and they are using 40% of the memory for the operating system and JDK and JVM, and 60% for the Mule runtime. But the minimum memory required for a runtime pod is 1 gigabyte, and 50% of that will be assigned to the Mule runtime.
Okay, understood. This question came from Philip Bruguera, just to let you know. And the next one is from Sajjan Patel. It's a question around the containerized Mule runtime is sharing only the operating system. Does each container get a virtual CPU thread or a vCore? What's the dedicated CPU when you talk about application isolation?
So in Kubernetes, when you initiate the creation of a pod, you assign it a fraction of CPU and memory, and you assign it disk space. And then the pod will be instantiated with those resources. That's the amount of CPU that the pod gets. And it's basically taken care of by Kubernetes itself. And that means that if you have let's say you have a 4-core license, and you deploy just a 0.5 virtual CPU pod, then you still have 3.5 CPU or cores left to assign to other applications.
Okay, excellent, Arno. We are still for 4 minutes more. Will you be okay to continue the Q&A for a little bit longer?
Yes, absolutely.
Okay, excellent. The next question comes from Philip Bruguera. It's about the Kubernetes deployment. If the Kubernetes deployment is without the mule control plane.
If it's without the mule control plane, so you mean you take a pod and you copy the application into the correct directory yourself, and then you run the mule runtime. It's possible, but you will have no management. You will not be able to stop, start, manage the application, change configuration on the fly. You will not be able to see the health of the application. So it's basically a black box, and the only way to test it is by generating traffic to the application and getting a response. So it's technically possible, but in an enterprise environment, I don't think it will be accepted, because you can't see if the application is still responsive unless you build your own management plane around the pod.
Yeah, and then killing the purpose of already having the cake baked for you and making it yourself.
Exactly. Yeah.
Great. Okay, Arno, the next one is from Ramchan. And the question is, when we use containers for deployment, is there any option where the metadata also can still reside completely on-prem, like we do in PCE?
Yes. So if you want to containerize your Mule runtimes and you're using PCE, so the metadata stays on-prem as well, there's no reason why you can't use containerization. But it will have the same limitations as I described in this presentation.
Yeah, agree on that one. And the next one is, if we use a third-party applications for logging, which are dependent on the Mule runtime, how do we implement containerization? If we use third-party applications for logging, which are dependent on Mule runtime, how do we implement containerization?
Okay, so that is a scenario where let me check, where in the server that has the Mule runtime, there's also third-party software that takes care of the logging. Is that correct?
Rajman, can you confirm? That is my understanding. Yes, he is confirming.
Okay, so if you containerize the Mule runtime, then you own the pod, so you can put in that image whatever you want, just like on a on-premise server. So if you want to use third-party software for logging, you can add that to the container. You can configure the Mule runtime to use that third-party software to take care of logging. So there's no change from the capabilities of a on-premise runtime if you decide to containerize it. If you choose to use Runtime Fabric, then it will be a problem, because Runtime Fabric does not allow you to change any settings or anything within the container. It's completely immutable. We provide the image, we provide the runtime, and all we do is take your application, deploy it into the container, and then start it for you. And there's no way to add third-party logging to that. So if you want third-party logging and containers, you would have to build that image yourself.
Okay, Arno, thank you for that one. We are in the last one because there's already time for the next session of Anu, and we're going to take first there's some winter feedback, great presentation, Arno, and what are some recommended resources, for example, of Docker files for creating images with Mule 4.2 plus the runtime?
So first of all, I would definitely choose Mule 4.3 because it's optimized. It has lower memory consumption, and it's all over faster than Mule 4.2. We've made a very big effort to make sure that Mule 4.3 is as fast as Mule 3, is faster than Mule 4.2. So we definitely spend a lot of engineering time making that happen. So that's our recommendation. For the container, I've seen, and there are many blog posts and articles and on fora you can find people that have already containerized their Mule runtime. So if you go on and find those articles, it's basically taking a JDK 8 base image, slapping a Mule runtime on top of it, making sure that you open up the right ports and run the AMC setup to connect to the platform if you want to run managed Mule runtimes, and then use the runtime or the platform APIs to deploy the application into the container when you start it. So that's a typical way of doing it. It's very well documented in some really good articles that are either on the blog sites or on fora about Mule runtime.
Arno, so I think we have reached the end of the session from Arno. Thank you, Arno, for all the time that you put into the presentation and making a great feedback for our customers. That's what we're getting right now. And yeah, I don't know if you have any other topics that you would like to mention before the Arno's presentation.
Nope, I'm good. I want to wish Anu best of luck with her presentation about batch. I'm very excited about that. And thank you for the opportunity, Angel. And thank you to everybody who attended.
Thank you very much, Arno. Excellent. Arno, I will leave the stage to you now.
Okay, thank you. Everyone can see my screen, I assume?
Yes. Able to see the screen and we can hear you all right.
Okay, great. So my name is Anu Vijayamohan. I'm a customer success technical architect at MuleSoft. As you can tell by my accent, I was born in America, but I'm based in London. I've been in the field for almost 20 years, aging myself. My previous role was mostly IT delivery and professional services. I worked for Appian for 13 years. I don't know if you've heard of it, but yep. And I joined this team, MuleSoft Customer Success, about a year and a half ago. So the agenda that I have today is about batch processing. So I want to cover an introduction to batch processing, some use cases, some features in Mule 4, some best practices for batch processing, error handling, performance tuning considerations, and everyone's favorite, certification tips. Let's start with an introduction to batch processing. Imagine you have sat down for a nice meal at a very famous Michelin-starred restaurant, and after a long wait, your meal comes out not as all as described, and on top of that, it's cold. Your impression of the quality of this restaurant will definitely be impacted. The chefs in the kitchen have a responsibility to be consistent and reliable in the quality of what they serve in order to maintain that Michelin star status. In the same way, your organization's processes have a responsibility to be consistent and reliable in the data that they send to external systems, especially at high volumes. Let us consider how MuleSoft can help you process large amounts of data with consistency, reliability, and data integrity. Mule 4 has a number of batch processing features available to achieve these goals. First, let's take a look at some appropriate use cases. Batch processing is particularly useful when working in the following scenarios: integrating data sets to parallel process records, or synchronizing data sets between business applications. For example, syncing contacts between NetSuite or SAP and Salesforce. This model allows you to achieve near real-time data integration. Another scenario is extracting, transforming, and loading information into a target system, what we call ETL. For example, uploading data from a flat file like a CSV into Hadoop. Finally, another common scenario is handling large quantities of incoming data from an API into a legacy system. There are a number of characteristics that API and batch have that differentiate them from each other, and these are important to understand when designing your applications. First off, availability. APIs are on demand and real-time and based on user interaction. Batch is a scheduled copy of a dataset and does not require direct user interaction. The profile of each also differ quite significantly. APIs have configurable fields and attributes that you can join, filter, and sort on, and are of a much smaller controlled volume. For example, 10,000 records per request. Batches are often, by definition, mostly static or changing very infrequently. The volume is much larger, millions of records and gigabytes of data. The data change frequency is also important to note. APIs are used when data can change in real or near in minutes, while batch is designed to cater for data changes that are much slower, for example, daily, weekly, or monthly. Consumers of an API can be multiple and undefined at design time, whereas batch is usually tied to a particular destination or set of destinations, and this will rarely change. Publication of APIs happens in an event-oriented manner, while batch is republished rarely once it is created. All of these factors play an important role in helping you decide the right design. Now, how can Mule4 help you with your batch processing requirements? The batch job scope in Mule4 provides a construct for asynchronously processing larger than memory datasets that are split into individual records. Within an application, you can initiate a batch job scope, which will split messages into individual records, perform actions upon each record, and then report on the results, and, if desired, push the process output to other systems or queues. Let's go into further detail of the 4 batch processing phases within the batch job scope. First, input allows connectivity and transformation. Second, load and dispatch splits up and batches records for processing. 3, process allows for multi-step record processing. And 4, on complete, allows for reporting on the batch job statistics. If we go a bit deeper into load and dispatch and processing, here we can see that the record queue is built in the load and dispatch phase. Each record is then processed by each step independently and asynchronously, with the record maintaining its state at each step. Failed records will be skipped in subsequent steps, and a batch commit can be used in a step to bulk write to external sources. And lastly, here's an example of what a batch job scope looks like in a flow in Anypoint Studio. But why bother using batch job scope? There are a number of benefits. First, data integrity. Batch job scope allows for the description of a reliable process that automatically splits up source data and stores it into persistent queues. Second, reliability. Batch job scope allows the processing of large data sets while providing reliability. In the event that the application is redeployed or Mule crashes, the job execution is able to resume at the point that it stopped. Third, efficiency. Because batch is asynchronous, and asynchronous processing allows for better use of system resources, your general efficiency will be better. In addition to batch job scope, there are a number of other features in Mule4 that help you work with batching efficiently. First, polling connectors like FTP, file, and database poll by default when used as an inbound connector. Also, poll scope. Wrap a non-polling connector with a fixed frequency or a cron scheduler. And for each allows you to loop through a collection, processing one record at a time, where sequential processing is important. Also, watermarks track updates since the last poll using a configurable watermark in a persistent object store. So when designing your batch applications, there are a number of best practices to keep in mind. Let's start with the batch processing basics in Mule 4. Mule processes a batch job asynchronously. Any event source that feeds data into a batch job must be one-way and not request response. The results of batch processing do not feed back to the caller. And the default settings you should be aware of. Process records are in blocks of 100. That is the batch block size, which of course is changeable, but there's a 16-thread default threading profile, and the default on record failure is to cancel processing. You can check out the Mule documentation for more detail. When designing your batch application, it is important to have a strategy. For example, pattern strategy is a standard solution architecture for batch processing that teams within your organization should be required to use, setting up a batch pattern that everyone should follow. An exception process should be used to demonstrate why or how a team's unique needs require deviation from that standard pattern strategy. An exception strategy requires you to think about the question, how do we handle errors and exceptions when and if our batch fails? Mule 4 error management capabilities are quite robust, and they support multiple strategies. Picking the right strategy depends on the business context and the use case at hand. It is important to formally capture and design around non-functional requirements, NFRs. For example, performance, error management, and security. If these aren't captured at the start, before you start your design, you could end up in a lot of trouble later. Once you've designed your application with a robust strategy, there are a few things to remember while running the batch process. Front-load transformation. Consider the transforming the data set before the processing phase begins instead of in each record individually as the first step. That will speed up your overall batch. Keep batch deployments separate from real-time deployments. When co-running multiple batch jobs, evaluate resources like compute, file space, and memory utilization. Chain batch jobs instead of running them in parallel, and note the failure points, recovery time, and impact to other jobs. Consider file sizes. Split file into multiple smaller files or limit fields, if possible. Large files can consume a lot of working memory. Evaluate chunked mode or file streaming mode. Watermarking source repositories also allows greater resiliency in your processes and simplified access to unprocessed data. There are also some best practices that apply specifically to streaming. Use streaming batch processes when writing to a file such as CSV, JSON, or XML, and be mindful of performance implications. Streaming data does affect the performance of your application, slowing the pace at which it processes transactions. Though performance slows, the trade-off is to be able to stream your batch processes. So you need to evaluate whether that's the right choice for you. Also, be aware of item access implications. Streaming limits access items in the output, so only one stream can access each item at a time. And a fixed size commit is an unmodifiable list, and it allows access iteratively to process its items. Streaming commit is a one-read forward-only iterator. Error handling can be really useful in creating reliable batch processes that preserve your data integrity in case something goes awry. When a batch step fails or raises an error, Mule logs the stack traces following this logic. Mule gets the exceptions full stack trace, and then it strips down that stack trace from any messages, and then verifies if the stack trace was already logged in the current step. If it was the first time, then it logs the error and shows the message as illustrated in the slide. Subsequent records with the same failures will not be logged for performance and log readability. Mule logs on a by-step basis though, so if another step also raises the same error, the runtime logs the same error again for that new step. When a batch job reaches the incomplete phase, Mule displays an error summary with every error type and how many times it had happened in each batch step. Mule logs are only at info level by default, and for more verbose logs, you should set your batch category to debug level in the application's log4j configuration. But a note here, use the debug level with care. This is definitely not advised for production environments. There are a number of configurable options for error handling at a record level. First, finish processing, stopping the execution of the current job instance and finishing the execution of the records currently in flight, but do not pull any more records from the queues, and set the job instance to a failure state, and the incomplete phase is then invoked. Or you can continue processing. The batch will then continue to process regardless of any failed records. And you can use the accept expression and the accept policy attributes to instruct subsequent batch steps on how to handle failed records. You can choose to halt the batch if the job accumulates a maximum number of failed records, at which point the execution will halt as above. But before you go live with all of your cool new batch processes, it's important to take into consideration performance and to tune your applications appropriately. Focus on each process step to look for specific code optimizations that you can make. And focus on transformation and any external connectivity logic within the process steps. Eliminate as much disk and network latency as possible to allow for maximum CPU consumption for record processing. And align performance tuning considerations with your current performance testing activities. Lastly, don't overlook disk input-output. Mule batch processing is a disk I/O intensive activity to provide for performance and reliability. Use as fast as possible local disk storage to remove the disk I/O contention, and use of SSD for Mule local file systems significantly reduce disk I/O contention. In this last section, we'll go over some of the certification tips that I have for the MuleSoft Certified Integration Architect exam. Some of the topics related to batch that are covered in the exam, which I've also touched on in this presentation, are the for each scope, the batch job scope, including the concepts of synchronicity, filters, and the pros and cons of using batch job scope. Also, bulk operations in connectors and streaming. It's important to understand these concepts and not just memorize them, because the exam questions will require you to problem solve, to look at the pros and cons, weigh the different options, and make the right decision. Also, learn by doing. Open up your Anypoint Studio and debug the code to understand what's actually happening and its behavior. That's it for the slides. I'm ready for questions, Angel.
Yes, Arno, thank you very much for the... We do have a couple of questions. One is related, I think it's not directly related with batch, but it's a of tools you recommend for Mule for performance tuning. I have a couple in mind, but I will leave that to you.
No, I'd like to hear your thoughts.
Yeah, there's two main documentations that you can use. There is one around the 4.3 tuning guide that you can see here, Sergey. I'm just sharing in the chat. And there is also a white paper that explains, it's around 40 pages that explains all you need to know about the performance. Sorry, 40 pages was in Mule 3. In Mule 4 is around 25 pages that explains the complete way that Mule 4.3 is working and how the performance works there, because it's a huge difference from 4.2 to 4.3, especially around performance. Some of the tools that you may need is when you think about performance tuning, you need automation for performance tests, just like you can do with JMeter, so that you can control the amount of tests that you're doing in an automated way, not manually. So I will suggest that resource. I will add the white paper after the session and into this into the chat. I will pop it there. And you can also think about a tool that you will use for your performance testing. Okay, that is one from Sergey Plasov, and there is another one for Srinivas that is, does anyone use file data streaming approach on Runtime Fabric? Is it streaming possible from SFTP to SFTP? And we don't have any answers yet.
Yeah, I don't think I have an answer for that one.
Okay, let's move to the next one. There was one around how do you handle a bad record in a batch that causes failure when doing a bulk insert of batch to a database, and then you retry the batch.
So in that scenario, I would, before you start inserting, check what the last insert was that was successful. So
Yeah,
a manner of
awesome.
watermarking.
Okay, thank you for that, Anu Sajjam. I think your question was already answered, and that was the last the last question we had. I'm just going to read some of the feedback. One from Tony, great presentation, Anu. Your voice is well suited for narration and voiceovers. Oh yeah, that's a reference probably to the American accent, oh, you already read it, sorry.
No, it's fine. I love compliments.
Yeah, especially when they read it to you, right?
Yeah, exactly.
So batch processes will use multi-thread or single thread?
So it's multi-threaded in Mule 4, and the default, as somebody there, is 16, but it is changeable. Always, of course, be wary of your system resources when making these tunings.
Okay, and we can do one or two more questions. I'm going to pick this one here. For ETL processing, would you prefer batch processing or parallel for each? I think that's a tricky question, actually, because I don't know if you want to answer on that one, Anu.
I feel like you had a thought, Angel. I mean, you go first and then I'll add mine.
Yeah, again, I'm saying, I know I'm repeating myself because I said the performance tests are important, but in this case, sometimes, not sometimes, when we do performance tuning, it's not a certain science. So there are cases where you will want to have your automated performance testing so that you can actually make the test for yourself. In some cases, it will be the payloads. In some other cases, payload size. In some other cases, it's the quantity of transactions or the period of search in those numbers of transactions. So the question here is, for ETL processing, would you prefer batch processing over parallel for each? I'm not sure if that will answer the questions, or you have any other input there, Anu?
No, I think you're right. I think it really depends on the use case. Batch, it's not an exact science. So because you're dealing with a lot of different types of data and doing different data transformations, it's really hard to give you a concrete answer, yes or no. But performance testing is definitely key. So have a plan for that no matter what you decide to do.
Okay. Those were the last two questions that I had in the plate. So with that, we finished the 2 sessions for today. Thank you for attending to this meetup. And Anu, thank you for a great presentation and for helping and supporting the community.
Of course, anytime. Thank you for having me.
Of course, Anu. Thank you, everyone. And with that, we're going to stop the recording. And thank you for joining. Tune in next week. We do have the Anypoint Studio 7.7 right from the engineering team in Buenos Aires.
Oh, exciting.